Let's prove some results rather than doing some calculations. Let's start. Prove that the tangents drawn at the end of the diameter of a circle are parallel. Okay, so we need to take circle, we have circle, take diameter, so this is diameter. At the end of the diameter, you need to take tangents. So first of all, let's label that PQ is the diameter, right? O is the center. So this is the tangent at P and at Q. Let's name it here XY and here MN. We need to prove that XY and MN is parallel, not perpendicular, parallel. Let's start with the given conditions. Given that circle with center O, right? Circle with center O. We have diameter as well. Diameter, which is PQ. Tangent XY and MN. Tangents XY and MN. Done? Now what we need to prove? We need to prove that tangents are parallel. Tangents are XY parallel MN. We need to prove XY parallel MN. Now here we need to remember the basic condition that we learn in grade 9, how to prove two lines parallel, right? You must have learned the topic of transversal. We are going to use that concept over here. Suppose, just imagining that these two lines are parallel and I want to say that PQ is the transversal. So there are few sets of conditions that we need to verify. You can take alternate interior angle which forms Z. You can take corresponding angles as well, or interior angles on the same side. Now when I say interior angles on the same side, how does it look like? Let's see, because I am going to use that condition. This is the transversal, right? These two lines are parallel. This is the one angle and this is the another. Let's say 1 and 2. And if I am adding them, I am going to get 180 degree. If this condition is satisfied, then I can say that these two lines, let's give L, M, N, they are parallel. Same logic I am going to use over here. I am going to use this condition. I want to prove that YPO and OQN, these two angles are 90 degree, and I am going to add them. And if I am getting answer 180, means these two tangents are parallel. Okay. So my first motivation is to get these two angles 90 degree. Now how can we get the 90 degree? We have learned in this chapter that tangent is perpendicular to the radius at the point of contact, right? So let's use that theorem first. Tangent is perpendicular. Tangent is perpendicular to the radius at the point of contact. Point of contact. Simple. Done. So what can we write? First of all, let's talk about the tangent XY. So can I write XY perpendicular OP? Yes. What about the second tangent MN? So I can write MN perpendicular OQ. Now what about the angles? This is 90 degree and so do this one. So can I write YPO? Let's write angle YPO is equal to 90 degree, and the second angle OQN, angle OQN is equal to also 90 degree. Now what I'm going to do, I'm going to add these two angles and check that am I getting 180 degree or not. Let's do the addition and check. I think we'll get 90 plus 90, 180. Very simple. So angle YPO plus angle OQN is equal to 90 degree plus 90 degree. So here it is 180 degree. Done. So I can say that these two angles are interior angles on a same side. So interior angles on same side, right? So these two lines are parallel. My final conclusion, xy parallel mn. We have proved it. Done. Xy parallel mn. Let's recall, it's very simple. First of all, you need to have a circle, draw one diameter, and at the end of diameter there should be tangents. Done. Now we used it for, and we need to prove that these two tangents are equal. Use the theorem that we learn in this chapter. Tangent is perpendicular to the radius at the point of contact. So this is 90 degree and so do this one. Add them, and if you are getting 180 degree, then these two lines are parallel. Remember, we used the concept of transversal to prove two lines parallel.